Today we will be finding a vector parallel to the line of intersection of the planes 4x plus 2y plus 2z equals 0 and negative 5x minus 2y plus 3z equals negative 6 using the point 1, negative 1, negative 1. Now, I'm about to show you a visual of what this kind of looks like when we find the line parallel to the line that's intersecting the planes. So the pencils represent the normal vectors that are coming out of the planes, and basically the line that is parallel will be the cross product of the normal vectors. So as you can see, the lines are parallel. That's the intersecting line right there, and this will be the line. And that line near the pencils is the cross products of the two normal vectors. Okay, so I went ahead and did the problem for you guys. So this is the first plane, this is the second plane. Now we need to find the normal vectors. The normal vectors are the coefficients of the plane's equation. So this is the first normal vector to plane 1, and this is the second normal vector to plane 2. Now the normal vector was represented by the pencils. You see that we're placed in a right angle. So again, the normal vectors are perpendicular to the plane. So that will help us to find the line that is parallel. So I went ahead and did the cross product. The reason why you do the cross product is because the cross product will give you a line that is perpendicular to the normal vectors, in which that vector that is perpendicular to the normal vectors will be parallel to the actual plane's line that is intersecting. Okay, so we're going to focus on the cross product. So the cross product, like I said, is going to give us the vector that is parallel. Because it is perpendicular to the normal vectors, it'll give us the parallel vector. So you do the determinant. So first you do the determinant for I, which is right here. Then you do the determinant for J, which is right here. And then you do the determinant for K, which is right here. So also there's like a rule to determinant. So you do plus, minus, plus. And it goes like a checkerboard almost. So for example, you could have plus, minus, plus, and if it was like maybe in three dimensions, I don't know, you would have minus, plus, so on. So this comes out to be like this. So I went ahead and simplified it for you, because you do, when you're doing the determinant, you do this multiplied by this minus this multiplied by this. So I got 6 minus 4. So 6 minus 4. So I did that for all the rest of them. So you got 4 times 3, which is 12, minus 2 times negative 5, which is negative 10. So you got 12 minus 10. Next we move on to K, which is 4 times negative 2, which is negative 8, minus 2 times negative 5, which is negative 10. So you got negative 8 minus 10. So obviously, you change the minuses to pluses. And so you get 10I minus 22J plus 2K. So that right now is the components for that vector, the cross product, which is the perpendicular vector to the normal vectors. So when we plug this in, using our point 1, negative 1, negative 1, for a line, you know that a line is x naught plus the vector times t, the vector component times t. So same with y's. You have y naught plus yt. Then you have y of t. So let's say x of t, y of t. And then you have z naught plus z of t. So these are all in respect to t, this vector. So you have 1 from the point plus 10, which is the component. And then you have negative 1 minus 22. And then you have negative 1 plus 2t. And you get that from K. So this is the equation of the line that is parallel to the intersecting line of the planes.